Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 3 to the power of n plus 9 to the power of n plus 27 to the power of n is equals to 24, and we will solve this problem for the real values of n. So that the very first thing we are going to do is, here first I can rewrite this equation as, here we have 3 to the power of n, I can write it as it is, and we have 9 and we will write it as 3 squared and its whole power n, plus we will write this 27 as 3 cubed and its whole power n, and this whole equation is equals to 14. And after that I can apply here the nice exponential law, and you know about this law, if we have a to the power of m to the power of n, so it is equals to a to the power of n to the power of m, and it is equals to a to the power of m times of n. So this exponential law just tells us that if you have exponent to the exponent, then if you can interchange these two exponent like in this form, here you have mn and you can write nm, so it cannot be affected on the final answer. So that here we need to interchange these two exponents, so that after changing these exponents we will obtain 3 to the power of n plus 3 to the power of n and its whole squared plus 3 to the power of n and its whole cubed is equals to 14. And in the next step I can convert this nice exponential equation into the cubic or quadratic form, so that here I can just take y is equals to 3 to the power of n. So when you can put here y is equals to 3 to the power of n, so this nice equation will becomes in the form of y plus y square plus y cubed is equals to 14. And after this step I can rearrange the terms, and I can write it as y cubed plus y squared plus y, and we move this 14 in the left hand side, and you get minus 14 is equals to 0. And after that we the next step is to find the factors of this equation. So in order to find the factors of this equation, I can rewrite this equation in the form of y cubed. Here you have y squared, and I can write this y squared as 2y square plus 3y square, and you know that 2 minus 2y square plus 3y square is equals to plus y square. Similarly we will write this plus y as minus 6y plus 7y, because minus 6 plus 7 will be equals to plus y, and minus 14 is equals to 0. And now in the next step we will easily make the factors of this equation, so that in the first two terms we will take common y squared, and you get here y minus 2. Similarly in the next two terms we will take common 3y, and you get y minus 2, and in the last two terms we will take common 7, and you get y minus 2 is equals to 0. And here you focus on all of the terms, and you see that y minus 2 be the common term, so that we will take common y minus 2 here, and the remaining terms will becomes in this form y squared plus 3y and plus 7 is equals to 0. So that here we have two cases. The first case is we take y minus 2 is equal to 0, and the other case is we take y square plus 3y plus 7 is equals to 0. And in the first case we get the value of y is equals to 2, and similarly we will find the values of y in the second case. So in second case, first I can check is this quadratic equation has real roots or not, because in this question we need only real roots, so that I can check its roots are real or not by using the discriminant formula. So that here we have a is equal to 1, b is equals to 3, and c is equals to 7, and our discriminant formula is delta is equals to b squared minus 4 times of a and c. And now we put all the values of a, b and c in this delta, and we can check that the behavior of delta. So that here you have the value of b is 3, so it will becomes 3 square minus 4 times of a is 1 and c is 7. So now we can simplify the terms, and after simplification you get delta is equals to the square of 3 is 9 minus 4 7s are 28, and 9 minus 28 is equals to minus 19, and here you see that our delta is less than 0. And according to the discriminant definition of discriminant, we can say that if delta is less than 0, then the given quadratic equation has no real root. And in this question we need only real roots, so that we will rejected this case, and we can just proceed here this case only. And in the start of the question we will take y is equals to 3 to the power of n, and now we can back substitute the value of y in this question, so that here you obtain 3 to the power of n is equals to 2. And now in order to find the value of n, we will take log on both of the sides, so that you will get the output in this form. And here you can just move this exponent in the front of this log, and you get n times of log 3 is equals to log 2. And now we can simplify the terms, and we move this log 3 in the right hand side, and you get n is equals to log 2 over log 3. So you can use the calculator or logarithmic table in order to find the values of log 2 and log 3, so that the value of log 2 is 0.3010, and the value of log 3 is 0.4771. And when you divide these two values, then you get the value of n is equals to 0.6308, and this is the our final value of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.